So today we're talking about similar triangles. For your essential question, I want you to answer what makes two triangles similar. Now for our vocab, we have the term similar figures. And similar figures are figures with the same shape, but not the same size. So when you think about similar figures, I want you to think about if you had a picture on your computer and you click and drag the corner to make the scale of the picture larger or smaller. Now, when you do that, you make it larger or smaller than the original picture, but it is still similar to the original picture because it doesn't get distorted. So you maintain that same scale. So with similar triangles, the angle measures will remain the same. So the triangles will have the same angle measures, but different side measures. So when we click and drag, again, we maintain those angles, but the side measures will increase or decrease. So here we have a few examples of similar figures. So you can see that these bats are exactly the same. One is just smaller than the other. You can see these chihuahuas are the same. Again, one is just smaller than the other, and these dogs as well. Then we have these two triangles, which are in fact similar to each other. And so angle B and angle E have the same measure, angle A and angle D have the same measure, and angle C and angle F have the same measure. So all of their angles are the same, but clearly their side measures are not. And what you'll notice is that this side here is 6 and this side here is 3, which means that the larger triangle is 2 times larger than the smaller. That being said, we would just take these side lengths, multiply them by 2 to get the larger side length. So 3 times 2 gives us 6, 5 times 2 gives us 10. And if we had this third measure, we would multiply that by 2 as well to get the third measure of the larger triangle. Now, that's called scale factor, the number you multiply by to get the other triangle. And it's not always so obvious what that scale factor is. Therefore, we use proportions to help us find those measures. Because what happens here is you'll notice that 6 and 3 are proportional to 10 and 5. So 6 divided by 3 is equal to 10 over 5 if we were to reduce this. And so what that allows us to do is use proportions with an unknown, so with a variable, to help us find the measure of a missing side. So for our first GP, find the missing angle for each triangle. Label each of the sides as small, medium, or large, then use a proportion to find the indicated side length. So first, we're looking for that missing angle. Remember from our last lesson, the sum of the angles of a triangle, the sum of the interior angles, will add up to 180 degrees. So to find angle B here, we're going to do 85 plus 42 plus B is equal to 180 degrees. So we combine our like terms. 85 and 42 are going to add up to 127. We will subtract 127 on both sides. And that gives us a measure for angle B of 53 degrees. Now that being said, D is also 85, F is also 42, so E is also going to have the same measure as angle B, and this will be 53 degrees as well. So because these triangles all have all three angles the same, these two triangles are similar to each other. And because they are similar to each other, that allows us to use proportions to find this missing side length. Now, before we do that, though, we want to label the sides as small, medium, large to make sure that we have them set up with what's called their corresponding sides. So when we set up the proportion, we have to keep the small sides together, the medium sides together, and the large sides together. So based on the way this is set up, we look at the angles. Remember, the largest angle is opposite the largest side, and the smallest angle is opposite the smallest side. So in this triangle here, 42 degrees is our smallest angle, which means the side across from that angle, 13, is our smallest side. 85 is the largest angle, so the side across from that is our largest side, which leaves us with this side as our medium side. So I'm going to label this one as well. And as I said before, when we set up the proportion to find the indicated side length, to find that missing side X, we'll use a proportion. And so what we're going to do is set up the proportion as small over small equal to, in this case, large over large, because we have no information about the medium sides. So small 13 over small 27 is equal to large 21 divided by the large, which is X. Now notice that I used the smaller triangle for both numerators and the larger triangle for both denominators. You have to make sure that these match up, so small over large and small over large in terms of the triangle. The sides are small over small and large over large. So to solve this proportion, we will cross multiply. 13 times X is equal to 27 times 21. So 27 times 21 is going to give us 567. We then divide both sides by 13, and that gives us a measure of 43 point, we're going to round that to the nearest tenth, 43.6 units. Now you want to go back to the triangle and make sure that this makes sense. If you know that you're solving for the largest side of the triangle, you want to make sure that your answer is larger than the smaller side or the medium side in terms of the triangle. So always make sure that your answer makes sense logically. Okay, so for GP number 2, we're going to do the same thing we did in GP number 1. So we're going to start by finding the missing angle of the triangle. So we're going to start by doing 29 plus 107 plus angle B is equal to 180 degrees. 29 plus 107 is going to give us 136 plus B is equal to 180. We then subtract 136 on both sides, and that leaves us with a measure of 44 degrees. So angle B is 44, and angle E is also 44. From here, we want to go ahead and label our sides as small, medium, and large. So based on the angles, 29 is the smallest angle, which makes X the smallest side. 107 is the largest angle, which makes this side the largest side, leaving the bottom as the medium side. And this bottom side here is the medium side. So we set up our proportions. The side we're looking for is the small side. So I'm going to do X divided by 3. So the larger triangle on top, the smaller triangle on the bottom is equal to. Now for the second proportion, because we don't have the measure of this large side, we cannot use it. So we're going to have to use the medium side, large triangle on top, 10 divided by smaller triangle on the bottom, which is 5. We then cross multiply. We get 5 times X is equal to 3 times 10. 5X is equal to 30. We divide both sides by 5. giving us a measure of x is equal to 6. Now, if we go back to the original triangle to make sure that our answer makes sense logically, remember that this was the smallest side that we just found. Therefore, it should be smaller than the medium side, and it is, so it makes sense logically. That is using similar triangles and finding missing sides.